Okay, so I was trying to get your homework assignment up, but uh, it was acting very funny because I'm trying to put XML code in there. So let's talk about this first, then we can talk about the exam, and then I'll give you the pieces that you'll need to kind of get started with this, and then we'll see what time it is. Maybe we'll get out a little early or something. For starters, because we're on break next week, this is going to be due on Friday. All right, so 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 there's gonna be two things I'm gonna be putting up tonight and probably tomorrow morning. I'm gonna be putting up this homework assignment that will just be a programming assignment, no paper, for this last thing. And I'm gonna talk about the programming assignment here, and I'm gonna also kind of talk through the breaking down of the problem. Okay, not in total detail, but I'm going to give you kind of a head start, because what I'd like to see is I'd like to see you tackle a relatively difficult final problem and succeed with it. Okay, it's going to be due in 2 weeks. So if you go away on vacation next week, that's fine. Work on it the rest of this week and work on it when you come back. All right. I don't care when you turn in. If you want to turn in sooner, that's fine, but you have 2 weeks to work on it. All right, should not take you any longer than the normal thing.
My question is with that though is, how soon are you going to grade it?
I'll grade it right away.
So if I did it right away, you'll.
As long as I won't be able to grade it between.
The reason why I ask is because I get reimbursed for classes.
Sure.
After I take them,
Yep.
It's based on grade.
So what you could do then is, as soon as you turn it in, email me and I can grade it right away. The catch is going to be that I'm not going to be able to look at it between Sunday and Sunday.
Next week. And now I'm fine with that. Not that I'm waiting until the following week, that Wednesday, and you're going to go through and grade it, and then it's another week before I get graded.
Yeah, just as soon as you turn it in, tell me, and I'll just remind me, and I'll grade it right away. All right, but so you have until what would be the normal start of class time, which will be 6 p.m. 2 weeks from today. Okay, we won't meet next week, even though grad classes are supposed to meet. I'm out of town, so rather than meeting an extra week, since I know some of you are traveling and stuff like that, just manage your time. You have 2 weeks to get this done. All right, so that's step one. There won't be a paper, just the final programming assignment. And then there'll also be a final exam, and I'm going to do that as an online exam through Blackboard as well. And you can complete it any time within the 2 weeks, but assuming it'll let me set it up right, when you sit down to take it, you'll have a total of 2 hours to take it. All right, so it'll be like an in-class exam, but you can take it whenever you want within the 2 week period.
So what will we expect into the?
Yeah, I'll talk about that here in a few minutes. So, makes sense? The high level, what's happening in the next 2 weeks?
Yes.
All right, so programming assignment that we'll talk about, and exam that we'll talk about.
So that 2 hours is like non-stop, just continuously?
I think yes, let's say yes. I'm not sure how Blackboard, I haven't done one like that before on Blackboard.
Just assume it's, you sit down, you need to have
Yeah.
2 hours.
Yeah, usually, so let's talk about the exam first. So usually what I do is I write exams to take, if it's a 2 hour exam, I write the exam to take 1 hour. So the average student should be able to do it in 1 hour. You have 2 hours to take it. So I don't want the exam to be a time stress type thing. That is to say, I want to see what you're capable of, not what you could do in the amount of time you had. All right, so you have full 2 hours. If it takes you 2 hours, you probably didn't know the stuff as well as you should have. Kind of make some sense? All right, so let me open up a keynote here and let's talk about what to expect on the exam. All right. Okay, final. It's going to be 10 questions. All right, approximately 7 will be short answer / essay on the theory material. And we'll kind of flip through the slides and I'll point out some of the things that I think might make it on the exam. Things that I think are important. Okay? And then approximately 3 will be programming. All right? So programming are probably going to come in the form of write a method that does something. So write a method that takes in these parameters and has this output. So probably 2 of them will be like that. Write a function, write a function. And then 1 of them will be a little bit larger where you're like create a class that does something. Here's a couple of objects, make them work together, do something interesting like that. Nothing will be big like the homework assignments, but you might have to create a, I don't know, let's say like a person object. And a person object should be able to hold first name, last name, and email. And then you should be able to create some instances of person objects and maybe, I don't know, display them to the screen or something like that. Prove that you can create objects and that you can use objects. Okay? But this is all something I would expect you to be able to do in like a 1-hour time period total, as opposed to a bigger homework assignment. All right, so that's going to be the final exam from a programming perspective. Okay.
Those 7 are from the slide.
7 are from the slides. I'm going to go through the slides and tell you what I think is important right now. All right. Now, you have your book. I mean, you have the notes and stuff like that you'll have available to you during the exam. If we were doing an in-class exam, I would probably usually have it as closed book, but there's no way I can police that. So I'll write the exam then with the assumption that you have notes sitting in front of you. All right. So that means I probably won't ask a question that's directly out of the notes. It'll be an application of it where you'll have to prove that you understand a concept as opposed to that you memorize something from one of the slides. Okay? So let's kind of step through our slides here. So this first section here on how human beings solve problems, what is computer programming, what's the job of a programming language, how we're too good of problem solvers to break problems down to small steps, so we have trouble articulating how we solve problems, and then ultimately the mapping, that our high-level programming languages give us this power tool that allows us to solve problems in a similar way to how we solve them in real life. That whole section there is probably going to have 1 question pulled out of it.
Sorry for interruption.
Yep.
Are you recording?
Yeah, I think so.
I was gonna say.
No, I mean.
Yeah, I am.
Yeah,
Yeah.
you can't write as fast. So.
Yeah, I am. Yeah, so that whole section will have probably 1 question pulled out of it. Something about what is difficult about computer programming, or how do human beings solve problems, or what's the job of a programming language, something like that. Something that'll have you prove to me that you understand how these concepts go together. Make sense? All right. I might ask you what a data representation language is. In fact, our homework assignment that we're going to talk about in a few minutes deals with XML, one of these data representation languages. So these guys are not programming languages, but still they're important. They're meant to organize data in a structured way so that we can send data between 2 programs or something like that. All right? So we should know those things. All right. Then we have this slide that deals with kind of how the web works. Okay, so there will probably be a question on this as well, dealing with client side versus server side, front end versus back end, the HTTP protocol, how web browsers make their requests to the web server using HTTP, web servers send their response to web browsers in HTML, CSS, and JavaScript. All right, and whatever it has to do in the back, on the back end using one of these languages possibly, or if it's just HTML, it will serve the answer. So understanding this world, understanding what MIME types are, how if we're requesting a .html file. It's just going to serve it because that guy is already in HTML, CSS, and JavaScript format. But if it's a .php file, it's going to have to go through some sort of preprocessor so it can send out run it through that program to generate HTML, CSS, and JavaScript. So understand how the web world works. Probably 1 or 2 questions from that. All right. All right, here's some examples of XML. We'll be talking more about XML here in a few minutes when we talk about our homework assignment. Okay, this is dealing with similar stuff. Certainly kind of the comparison here, PHP versus Ruby versus Python versus Node.js. Very likely a question dealing with maybe what was one of the strengths or weaknesses of Ruby? What was the weaknesses of PHP? Maybe something with design patterns. What's MVC? That type of thing. So something dealing with this slide. How these various web technologies from an evolutionary standpoint compared to each other. So we talked about design patterns. That can make the test. Popular design patterns, I might ask you to give an example of a problem that would, where the observer design pattern is prevalent or something like that. Or how is MVC used in some language? I'd have to give it something high level for us here because we didn't really do this in class from an application perspective, so I probably would have to ask it as a more generalistic type question. I wouldn't ask anything about Xamarin. I could potentially ask about denial of service or distributed denial of service, specifically because this is an IT class. So that was part of the conversation about Node.js when we talked about this guy right here, how web servers can get overwhelmed with too many requests. So if you go back and listen to that lecture, that's what we were dealing with that. So this is the denial of service attack and a distributed denial of service attack. So a reasonable question might be, how does Node help us avoid DOS or DDoS attacks? Something like that. Obviously, these are important, but I wouldn't ask you to list all the languages or anything like that. I think that's a waste of time. I like these kind of slides. These evolution of C, evolution of C++. Very likely there'll be 1 or more questions from those. What was the problem with C? What was the problem with C++? So we get into those. These would be fair game, but out of the different types of programming languages, I would never ask you anything about functional. I might ask you something dealing with object-oriented languages, functional versus object-oriented. That was our discussion about, I think I probably used the telephone as an example. Okay, yep. Oh yeah, there's the telephone.
So there will be nothing from homework assignments, but
Oh, for the papers? Yeah, there could be. There could be. But typically, if you look at your paper homework assignments, most of them were based on something we talked about in class. So having said that, if I was asking something conceptual from those papers, it would be I would be asking, based on your research, what could you prove to me that you understand this concept, as opposed to something very specific that half of you may be uncovered in your research. So I probably wouldn't ask something like that, but I might ask a higher level question, proving that you kind of understand a concept. I do kind of like this subject, machine language versus low level versus high level, specifically the nature of the CPU. So, if I were sitting here writing the exam right this second, I could see that making an appearance. I like that, not really looking at zeros and ones, but I like that idea of, understanding this one-to-one relationship with the CPU as it relates to our CPUs, kind of like a collection of magic tricks where you do them in a certain order and something magical happens. Where our high-level languages are kind of our power tool, that we get to write 1 or 2 lines of code and a whole bunch of stuff is happening behind the scenes. All right. So I would put a pretty high priority on this slide, along with the next couple, like the CPU discussion here. Yeah, and I think at this exact same time, I think we looked at Hello World and assembly language. So, that type of thing. I mean, I probably wouldn't put like an assembly language program on the exam, but that whole section dealing with how a low-level language works with the operating system and how high-level languages make our life easier, that kind of stuff, I put a fairly high importance on. Evolution of C++, kind of what was the problem, explaining this, how the programmer's empowered to make bad decisions. The concept of side effect, when something's passed by value versus passed by address, and what that means. And that's all in the same conversation as pointers. Structs first classes would be fair game, but I would have to be digging for an extra question. So I'm trying to give you some insight into my head if I were writing this exam. I would have to be desperate for an extra question to try to pull out what's the difference between a struct and basically what's a struct versus a class without methods. Remember the kind of the mistake Java made, where they chose to get rid of structs in the Java language, kind of thinking that a class is effectively, if you write a class and don't put methods in there, it's effectively a struct, only sort of, because they're actually passed, one's passed by value, one's passed by address. So I would expect you to understand that concept, but I probably wouldn't ask it unless I was short a question. Similarly here, this idea of automatic garbage collection from Java, how in Java it cleans up our memory for us. If I was desperate, I might grab at that. I doubt that will be the case, so I probably would not ask that. Evolution of Java. I could see there being one question that kind of spans those evolution slides. Maybe kind of comparing 2 or 3 of them together or something. So this idea of, Java, what do? They removed a lot of lines of code, so that kind of hides a lot of stuff from the end user. Certainly the virtual machine aspect of Java, platform independence, kinds of programming languages, compiled versus interpreted. I could see asking a question about this relatively fast versus relatively slow stuff. So compiled versus interpreted, and then loosely typed versus strongly typed, which is going to be coming up here in a couple slides somewhere. So how compiled strongly typed languages are relatively fast, interpreted loosely typed languages are relatively slow, and then maybe asking the follow-up why. Explain why they're relatively fast versus relatively slow. What's a compiler? I mean, I probably wouldn't ask it so straightforward, but that goes in with the compiled languages here, so you should understand that. Understand how Java works. When we go from our high-level source code, compile it into bytecode, it runs through the virtual machine, which converts into native assembly, and it runs on the CPU. So understand that process, that throughput. I suppose I could ask a question about, the Microsoft backstory, but I would have to be desperate for a question. It's interesting, but I probably won't waste 1 of 10 questions on effectively a commercial or something like that. Potentially, if in this discussion, how Java versus C# in terms of how a Java program is compiled and run versus a C# program with a .NET component architecture, and maybe something along the lines of what does Microsoft mean when they say C# is platform independent? Technically, it'll run on any platform as long as it's Windows, because it only runs on anything that supports the .NET component architecture, which happens to only be Windows. Similar here, this would be in that same ballpark with the Microsoft backstory. If I was desperate for a question, it's possible, but I would think that I probably wouldn't pull a test question off of this. So this is starting to get into Java specific stuff. Certainly Boolean expressions, what are they used for? I mean, this would be fair game, the whole thing, any expression that boils down to a single value of true or false, that's what a Boolean expression is. They're used in conditionals and loops. Difference between pre-check and post-check loops, maybe. Higher percentage chance than the Microsoft or Apple backstory stuff, but I wouldn't put it real high up on the priority list. Variable scope, pretty important. So I would say that if I can come up with a decent question dealing with where you have access to a variable, that would be fair game. Maybe I'd give you an example and tell you to, what's the output of this program. So that would fall into the category of a theory type question, where even though I've written some code, I might say, what does this code do? And you're reading through the code and not writing it, but you're showing me you understand what it does. And so I might use that as a way to ask something about scope, where I have a couple of variables that have the same name but are technically in different scopes. And you'll have to be able to differentiate what the actual value of something will be during runtime. I mean, those guys would be fair game, but I can't imagine I asked a question about the specifics of plus plus and minus minus. I do like conversion questions. I could see me putting a conversion question on there. Convert between, some number in hexadecimal to binary, or some number like 200 megabits per second, how many megabytes per second that is, or I might ask you how many gigabytes per second, or how many bits per second, whatever. Do some weird conversion stuff. I like those kind of questions. All right, so this is kind of the Y2K discussion, why we have so many different primitive types that for holding whole numbers. I could see asking a question along those lines. Why are there so many different integer-based primitive types in Java? And that deals with the Y2K issue. Memory used to be very expensive. Might ask a question about Unicode, the char primitive type. Why is the char represented as an integer when we think of them as characters? Certainly be able to read code dealing with strings. So if I give you a function or give you some code that has string manipulation in it, I kind of like string manipulation. In fact, your homework assignment's on string manipulation. You should be able to follow it and tell me what the output would be. Be familiar with the various string methods, if for no other reason than being able to read code that I put in there, and also being able to write the code for your functions. Yeah, so the idea of arrays, certainly an important subject. So, why do arrays require contiguous memory? Kind of understanding this slide here, their index 0, 1, 2, 3, 4, which map to contiguous memory addresses in memory, and the values live at each of those memory addresses. Why do arrays require contiguous memory? Which also means it's also the same reason as why they're fast. Okay, because the elements are right next to each other. The job of the new keyword, you should certainly understand that. I could see that falling into a programming, not a programming question, but a theory, well, possibly a programming question, but certainly a theory question where I show you some code, I ask you what the output is, and I purposely try to print out the value of an object, which should be a funky memory address, seeing if you will catch on to that, or you try to say it, you think it's like a, the fraction 1/2 or something when it's actually a funky memory address. Kind of the same things we did in class when I kept tricking you on it. So that type of thing. So be on the lookout. Concept of recursion. We actually saw a pitfall of recursion today. We called the play function too many times recursively and ran out of memory on the stack. Right? So I mean that's a pitfall of recursion. I suppose I could ask a question on time complexity problems, but it would be pretty low priority. There's plenty of material here for me to ask 10 questions from. I can't imagine that I would stoop to that one. The this keyword, pretty important. I'll probably try to find some way to make sure you understand that concept. It might not be a direct question, but whether it's code that I write or whatever, I want to make sure that you understand the this keyword. Similarly, security stuff, public, private, protected. Getters, setters, accessor, mutators. I probably won't ask a question specifically about those, but you should understand the need for those things for accessing private members of a class, that kind of stuff. Class methods versus instance methods. That is, methods that are owned by the class that have the keyword static in front versus methods that are owned by an instance of the class that do not have the keyword static out front. Pretty high priority. You need to be able to read documentation. I could certainly give you a fictitious class and a fictitious function definition and tell you to show me how to call it. So you should be able to read and know that if it has static in front of it, you have to call it with the name of the class. If it doesn't have static in front of it, you have to first create an instance of an object and then call it using that instance. You should understand those things and prove that you know how that works. The idea of inheritance, how that model works. We talked about this last time where you have an object and at the very top level, and then you have things that fall underneath that object, things that fall underneath that. So a wizard is a fighter, which is an object. Probably wouldn't quiz you on this, but this is a pretty important word to be familiar with, polymorphism. More than one method with the same name but a different number and or type of parameter. Concept of abstract, creating a class specifically for inheritance. I can see possibly writing some code that uses something with abstract that kind of forces you to understand that it's abstract. I might write some code and ask you to tell me what's wrong with this code. So forcing you to look at the code line by line and ultimately say, oh, well, this is why this shouldn't work. You're trying to create an instance of an abstract class, and that's not allowed. That's against the rules for abstract classes. Okay, so questions about that? So hopefully I've gone through in reasonable detail and kind of hit the highlights of the trip.
It's 6 p.m. 2 weeks.
2 weeks from now, yep.
At 6 p.m. it starts?
No. You can complete it anytime. I'll probably put it up tomorrow morning sometime. You could the final exam. I'll probably put it online tomorrow morning, and you have any time. You can do it any time within the next 2 weeks.
So you can do it tomorrow night if you wanted to.
No, I don't want to.
Just saying. It just has to be submitted by 6 p.m. 2 weeks from now. Get it? All right. So you get to manage your time.
An assignment too?
The assignment too. Yeah. So I realize some of you are traveling, so manage your time. You're all adults, so I'm giving you 2 weeks to work with. All right? so you figure out how you want to spend your time during those 2 weeks, and at the end of the 2 weeks, I'll look at it, unless, like you said, if you need me to specifically look at it early, just tell me.
No, and I'm fine with that.
Yeah,
I mean,
it won't bother me.
Yeah.
I'm back starting on the 20th, so I can look at it right away. then if you want. Let's see. Okay, so that's that. So let's look now. I need to find the right way to get this up on Blackboard. I might have to load it into a file first. In fact, I probably will have to load it into a file. So what we're going to do for the homework assignment, we're going to talk a little bit today about file I/O. We'll see if we get out early or not. Who knows? But so I'm going to basically give you enough information to read in a file that looks like this. Okay, read that in from the code. So we're going to put this into a text file, something that is, I'm calling it a simple XML. So you can go and look up XML on the web, and you see that actually XML supports things like, you know, these things called attributes, you know, that kind of stuff. You don't have to support that in this assignment. Okay, so I'm calling this simple XML, that is only opening and closing tags. Nothing inside of the tags themselves. So attributes aren't a thing. So it'll be things that look like this. So I tried to give you a relatively complex-ish type of example here. So if you read in an XML document that looks like this, it should output something along those lines, proving that you were able to walk through the document one way or another and extract the values. Okay? So if we kind of look at this, this is an opening tag, so I burn past that. Here's another opening tag. That's the opening tag for first name. So notice I hit an opening tag, I printed it out, followed by an arrow. I hit another opening tag, I printed it out, followed by an arrow, followed by its value, Mike. I hit another opening tag, so I knew the value was over when I hit the closing tag here. Then I hit another opening tag, LName. LName arrow, got its value, read everything up to until the closing tag. Littman, opening tag age, read everything up to the closing tag, 15. Opening tag address. Then I hit another opening tag, number, so this is an object inside of it. 123, street, Elm Street, city, Grafton, state, Wisconsin, zip 53024. All right, so you're proving that you can start walking through this. This is an opening tag. Here's another opening tag. So what do I do? Okay, well, first of all, do you understand what I'm asking you to do? The high level. Okay, so now I'm going to give you some hints on how I would go about doing this. So this is where you probably want to take notes. All right? This is not anywhere near as hard as you probably think it might be. But that's how most assignments are, right? So I'm going to ask a question here. First of all, how do we identify this guy as an opening tag as opposed to a closing tag?
Backslash.
Okay, so,
Forward slash, I'm sorry.
right. Opening tags lack. They don't start this way. So closing tags start with a less than slash. Opening tags start with just a less than. So that's how I can differentiate something that looks like that. So if I hit something just in that less than, I know it's a tag. The next question I need to ask is what kind of tag? Is it an opening or is it a closing? So I need to peek ahead at the next character. The next character is a slash. That means it's a closing tag. If the next character is something other than a slash, that means it's a opening tag. All right. Now, so here's a statement of fact here. Every single time I wrote a tag name followed by an arrow, that's what I did for an opening tag. I hit an opening tag. That's what I do. Opening tag. That's what I do. Opening tag. That's what I do. Over and over and over again. So when I hit a tag, what do? I ask, is it an opening tag? If yes, what do? I do this. The name of the tag followed by an arrow.
So we are writing a Java program
To read this from a file
and give out
and output this to the screen. Okay?
I was thinking we have to write XML code.
Well, I mean,
That would
no, actually pretty easy. Like,
yeah,
if you wanted to output your card in XML, I mean, seriously, I want to demystify that because it's an important thing. I mean, couldn't we write a function here for our card? Just call public string export to XML. And wouldn't this guy just create a string answer? And this guy would be, probably opening card like that. And then at the end, we say answer is equal to, well, let's say answer plus equals closing card, like that. And then in the middle, we're going to have an opening closing suit. So we would probably do, well, let's do these on individual lines. So we'll say answer plus equals suit, answer, so I'm going to steal this line here, slash suit, and I'll put this dot suit in there. Similarly, we'll do the same thing for display value. So maybe we just call this face, face, this dot display value. Finally close the card, return answer. Doesn't that export a card to, so if I go to my deck and I have a display, rather than displaying the entire deck, I can tell each card to export to XML, and I can do a system.out.println like that. And now when a dealer first creates the deck here, what we can do is we can just, the deck should get shuffled. So we'll say this dot the deck dot display. So when we first create a dealer, we'll have him go ahead and display the deck. And what does the deck do? The deck goes ahead, when it displays, it goes through all the cards in the deck and prints out each one's exported to XML. So there's our entire deck in XML. That makes sense? I mean, when you look at XML like this, it seems like, oh, that's not something that's that easy for human beings to work with. But that wasn't that hard what we just did. It was mostly just tedious writing 5 things in a row, concatenating some tags together, right? Okay, and now it can work in XML. So that's really what we just saw is almost the motivation for why XML and more recently JSON exist. Because it gives us structure for stuff. All right? But for you, you're going to be reading in from a text file, which I'll show you how to do today. Something that looks like that. And then you'll be outputting this to the screen. So read in from a file, parse it, walk through it, make sure you can recognize opening tags and build up values, that kind of stuff, and then spit it out to the screen. So every single time we hit an opening tag, we do something like this. Tag name, arrow. Then what do? We collect everything up till we hit a closing tag. Spit it out. Okay? Unless we hit another opening tag. So for instance, right here I hit an opening tag, so what did I do? I did the opening tag thing. Then I tried to read in a value. White space, white space, white space, white space. So this is non-value, something that is something that's empty. So I kept reading in spaces. The next thing I read in was a tag. And what do I do when I read in a tag? I do this. Now, I don't care if you kick it down a line or not. If you want to put all this on one line, that's fine. It doesn't have to look identical to this. I just want you to prove that you can extract the values. Does that make sense? So, I'm trying to talk this through in the way that I want your mind to think. When you hit an opening tag, what do? Maybe you call something called process opening tag. And what does process opening tag do? It reads in the opening tag, gets the name of the tag, spits it out to the screen with an arrow. That's what that function does. All right? Then what do I do after I process an opening tag? I process a value. And how long do I process a value for? Until I get to another tag. Now, if I'm processing this value, I'm doing it up until this tag. And I notice this guy's actually a closing tag. But if I'm processing this value, and the next tag I run into is an opening tag, I know that this guy didn't have a value. His value is an object. His value is this crap, the stuff embedded within there. That make sense?
Yep.
All right. So break this down into little tiny steps. Ask yourself, what do I do when I run into an opening tag? What do I do when I run into a closing tag? What do I do in the middle? Write functions for those things so that when you hit an opening tag, what do? I call process opening tag. When you hit a closing tag, what do? I call process closing tag. When you're in the middle, what do? Process value. Make sense? So if you can abstract it down to those things, you'll find this is actually pretty easy. Okay, so questions about this?
How do you get the text from another file?
Yep, that's what we're going to do right now. So I'm going to give you this as an example. So I'm going to start a new project. So we're going to do new Java project CSC535 XML. Oh, actually, I like to do the.
And you can actually upload. Are you worried about putting that XML file somewhere? The XML file you can upload.
No, the problem is if I paste it into where I put the assignment in, it doesn't format right.
You can upload it up through GitHub if you wanted to.
Correct. Yeah. I was just trying to do it directly, like I usually put the assignments up, and that HTML box does not enjoy it at all. Okay. In fact, what I might do is I might even just upload this code as your starting point. What we're going to do today, embed the assignment in there, and then for the assignment, I'm going to say read GitHub. I'll give you the link to GitHub. So then it's a twofer, right? You get starting code.
You can upload
And
a file to content folder and
yeah, I don't know. I don't like doing that. I don't like uploading files. I'm just lazy. I'd much rather program it.
then other option is to play with the HTML.
Right. No, I did that. Yeah, I didn't like that either. All right, so here's 535 Spring 2016 XML parser. And let me close all of these files here. And we'll create our new class, driver. I think I'd shown you this before. You can actually tell it to go ahead and create a method stub for main if you want to. I usually don't because I have to take half these comments out, but it's not like it's that big a deal. All right, so there's our starting point. All right, so now what we're going to do is I'm actually going to create a new text file in here. I'm going to have to show you something kind of, I don't know, almost an Eclipse special thing to do. Because if I put a file in here, so I'm just going to create a normal file. And we're going to call this guy input.dat. You can call it whatever you want. I just happen to call it input.dat. I'm going to go ahead and paste my XML in there. All right, so that's my input file. Now what I'd like to do is I would like to read that file in and be able to just spit it out to the screen. That's what I want to be able to show you today so that you could read something in from a source file, do something with it. I'm not going to do anything with it except for just print it out to the screen, proving we read it in. So we're going to do this with, well, a couple different ways we can do this. So I'm going to go ahead and go to the documentation, and we're going to look at a file reader. So java.sun.com. We'll go to Java SE and then APIs. I wonder if anybody actually goes to java.sun.com anymore except me. Oracle's owned them for so long now, but I'm still stuck on this URL that I remember from just years ago. All right, so we're going to be using something inside of the library called java.io. Okay, this is for doing input-output stuff. By all measures, Scanner should probably live in here, but it doesn't. Scanner actually was added to Java much later. Scanner has not existed in Java since the beginning. In the early days when you had to do I/O with Java, it wasn't horrible, but it was far more difficult than doing it with Scanner. Scanner made that significantly more simple. All right, so I just clicked on java.io here, and we're going to scroll down, and we have something in here called a file reader. Okay, so when we build a file reader is an input stream reader, which is a reader, which is an object. So here's kind of object-oriented stuff. All right, now if I'm just going to click quickly on input stream reader. Input stream readers can read things a single character at a time. Okay, that's what they know how to do. Read things a single character at a time. We really like reading things in chunks, string-sized chunks specifically, right? All right. But we're going to still stick here and look at this file reader. So this guy is a file reader, which is an input stream reader. So now I'm going to go back to java.util. And we're going to look at our scanner. We'll go to the constructor for scanner. We always pass it system.in. First of all, scanner can read in specifically from a file if we'd like to do that. It can read in from an input stream. This is a file as well. And we can also read stuff in from a string source. So if I can provide this guy with an input stream, like we've used system.in, Scanner will read stuff for me. Well, let's go back to file reader. This guy's an input stream reader. An input stream reader requires an input stream to read. Well, how do I get an input stream? Let's look at input streams. Go back to java.io. Here's something called a file input stream. Where is that guy? File input stream. So I can create a file input stream using a string name. And this is the name of the file that we want to open. So I'm going to go ahead and create one of these. So I'm going to say file input stream fizz is equal to new file input stream, and the name of our file is input.dat. All right, and it's going to want us to import java.io here. All right, so we have that. Now this guy potentially throws an exception. It says you might run into a file not found exception. Okay, so a couple different things we can do. Have we done any exception handling in here at this point? Okay, so this is yelling at us saying that we possibly have an exception. So we can try to do this and catch an exception if it occurs. So this is the local way of doing it. So we'll try to read in our file. We'll try to create our file input stream. If something bad happens, we'll catch the bad stuff, and then we'll just print out the error. The thing that would be bad would be that the file was not found. Okay? And so what I'm going to do here is I'm actually going to run this because we think we have a file called input.dat, right? File not found exception, input.dat, no such file or directory. Okay, well, we wrote one, but we don't see it here. The problem is that we've told it where we think it lives. The reality is what it's checking right now is inside the bin directory. Remember when you set up your GitHub? There's two directories, a bin and a source. We are looking at it here in the source. We put it in the source directory. But when we compile the code and it runs out of the bin directory. So this guy right here is looking in the bin directory, but the file actually lives in the source directory. So there's an Eclipse trick. I need to look it up real quick to get the full path. Let's see. Eclipse read file path. Yeah, this is what we want. Get resource stream. Oh, that's actually interesting. That's actually a super cool way of doing it. Class get resource as stream. Oh, then we can use our scanner. What was it? Get resource
As stream.
input.dat, and just wants me to import util. I no longer need these guys. While input dot has next, probably has next line, but whatever. Yeah, we'll do has next line. We'll say system.out.println input.next line. There's our output of our file. That's super slick. I did not know that a class could get its resource stream like that.
So we can use that then?
Oh, I want you to use this. Yeah, I'm going to give you this code as your starting point. All right, so this takes you to your file. You're already used to using the scanner. If we weren't going to use the scanner, I would have used the buffered reader to do this, which would have had us dealing with those exceptions and stuff, which is good to know, but we don't have to know them for this, and if we can keep this simpler, we will. So this will, instead of using our standard input stream that we've been using before, system.in to read from the user, now we're reading from this input stream associated with this file. Using the scanner to read it, as long as there's more things in there, go ahead and print them out to the screen.
Now, with this get resource as stream, that's as long as that file's relative to where that class is, correct?
Correct. If for all intents and purposes for us, as long as it's in our package, it's here. This finds it inside the source. Yep. So this will read in all the lines of that file one at a time. So this was the first read, this was the second read. So what you might end up doing is you might end up doing this. String file contents is equal to the empty string. And then you might say file contents plus equals input dot next line. And then at the end, do a final system.out.println file contents. So here is your actual file now as a string, single string. So now you can start walking through this string one character at a time. Make sense? All right, so then having said that, let me put, I'm just going to create another file in here. And we're going to call this guy assignment. Oh, probably need to actually grab the assignment from here. There we go. So that's what your output should look like. That's what your input should look like. So now what I can do is I can go ahead and put this on GitHub and send you a link for the homework. So let's do that. First, let me get the, go into GitHub, create another repository, CSC535, spring 2016, XML parser. All right, and I'm going to need that guy. All right, so we're going to do get init, dot, git commit -m. All right, get, is it push first? Yep. Origin, master. All right, so there is the code for that. So let's go into Blackboard. So programming assignment number 7. Here's the Git repo. Here's the homework instructions in the repo. So I'll link directly to those instructions as well. That's this. And this is going to be due by the 23rd at 6 p.m. All right, so that guy is up there. And I'll hopefully get the exam up tomorrow, but I might have to mess with that a little bit. It will definitely be up before I get on my cruise ship on Sunday. One way or another, I'm planning on doing it in the morning. So hopefully it's not as much of a war as I expect it to be. Yeah, I'll put it on Skype, but I think Blackboard sends you a email whenever I put something new up. Like, I'm pretty sure you just got an email.
No, it doesn't.
Are you sure?
Yeah, I'm sure.
No, if we log into it, it'll notify us
Yeah.
that a new assignment.
If you log in. it
Oh,
shows
see, I think there's a way you can set it up.
No, the
I'll throw on
notification-
I'll throw on Slack.
It'll,
The notification up, that the red sign, it's just when you go through the portal, through the.
Yeah. Once I log in,
Blackboard.
it'll notify.
Yeah, I don't know how they do it, but there is a way for you to get an email whenever one of your teachers puts like a grade up or you know, or an assignment or something like that.
You can sign up on Blackboard that
You can like enroll in notifications for it.
We didn't have it before, did we?
No, we have.
Well, regardless, I'll put it out once it's up. I'll throw it on Slack.
Okay.
But there's like a 98% possibility it's going to be up tomorrow, like early in the day.
That's fine.
So
Which is,
I don't want to fart around with this till Sunday. The plan is it's going to be up tomorrow. All right. So questions about the homework assignment? And so no paper this time. Is that good or bad? I'll give you an extra homework assignment.
Oh,
Extra credit?
Extra program. You want extra credit? What do you need extra credit for?
I don't need it now.
Wait till the test. All right, so 2 weeks to do the programming assignment, 2 weeks to do the final exam. That'll be up tomorrow. If you have questions, do communicate with me. But I will not. It's very likely I will have extremely limited email access from about midday on this coming Sunday until the following Sunday. Because I think this cruise ship has crappy internet. The last one we were on, the internet was amazing, but this is one of the older ones, so assume I won't be able to talk back.
So we just have 7 questions, like 7 questions, like short answer and 3 calls.
Yep.
And then
3 programming.
Okay.
Yep.
But one of them is just have a class and something, and
2 of them will be write some methods. 1 of them will be something more object oriented.
All right.
Make sense?
Yeah, thanks.
Questions, comments, concerns, bribes.
Assignment grade
For which?
for the last 2 assignments.
Oh, you mean the programming assignment and the paper?
Yes.
Oh,
5 and 5 and
I'll have them in there in the morning. But the assignment before that we're all done.
Yeah, we just.
Just the one that was from last week I didn't get to. Yeah, I'll get it. I'll get it tomorrow. I've had a busy week.
Cat morning.
No, we're past that. Just busy. Leading up to the trip and condo shopping and all this other stuff. All right, so